some of the temperatures that we talked about a moment ago in terms of what happens in a water-cooled or an air-cooled engine in terms of heat loss.
The internal combustion engine fundamentals.
The internal combustion engine fundamentals, and what you're seeing here are the temperatures that these surfaces achieve right at the very interface of the combustion chamber.
So here at the top of the piston we're getting about 550 to 575 degrees Celsius.
That's right. And what happens is that the heat then is carried immediately into the oil off of that surface and thus into the cooling system.
So the oil on the wall, it gets transferred in here and then into the cooling system itself.
Well, yes, but there's cooling oil that gets splashed on the piston to carry away that heat.
Ah, yes.
And you can see the cylinder walls get quite warm. And the head components, and particularly the valves, get very hot. That heat transfer path then goes to the outside world as a loss.
So the walls are going to get hot, the cylinder valves are going to get hot, everything around this is going to get hot with a gasoline internal combustion engine.
That's right.
And we're going to show a hydrogen engine, and this is not happening in here, so this is how we're getting the higher efficiency.
That's right. This is how we...
Here we got combustion gases. Here we go. It's in Fahrenheit, 4,500 Fahrenheit. The spark injector plug is going to get to 750 to 1,500. The top of the cylinder wall is going to get 200 to 700. The bottom of the cylinder up to 300. The rod and the bearings and the engine itself is 2 to 400. The piston skirt 2 to 400. The top of the piston ring. And this is all wasted heat that we don't want to lose, that we want to change into horsepower that goes to the shaft, which goes to the wheels, which moves us down the road.
That's right. What happens here is that these are current robbery paths for heat that's being made unavailable for expansion and work. But on retrofit with a kit like this, you're able to dramatically reduce those temperatures so the temperature gradient that exists is more that of a compressor than an engine.
So we just charged up this little bottle right here.
That's right.
And it was more than a charging demonstration. You're going to show us here where with this little injector what this can actually do?
Well, we're going to show how any engine can be retrofitted with a combination fuel injector and spark plug, which we call the spark injector.
So this injects the fuel and does the spark.
So it gives you a wide variety of operational modes.
Let's see the spark.
You can make it so that it's a spark for igniting gasoline only, or, and in that regard it is just a system that is ignition. Or you can make it so that it has a small amount of hydrogen that then gives new nucleation of many new places for making gasoline burn faster and much more complete. I don't know if you could see it, but there's a little bit of hydrogen that was burned that time, but I'll burn a little bit more.
Whoa! Oh, let's see that again.
I can make a little bit or a lot. Then if you want to go
a lot. They're screaming at me, a lot.
Then if you want to go to all hydrogen power.
Whoa! Oh, okay, hey, I'm standing back.
Then you do so.
Do it again. So that is what we really want to happen down in here in the cylinder.
Within surplus air.
Within surplus air.
All for the purpose then of making sure that you have more air present because you didn't have a vacuum during intake, and now that you can burn more fuel on demand to produce much more power than before.
I want to see that again.
I just turned it off.
Oh, gone. That's something. Now, we're hearing the bang of the hydrogen. It's burning so fast it's making a little bit of a bang for us. That's part of the reason it's burning so fast that it's creating that wave that we can hear it.
That's
now,
true.
but doesn't hydrogen burn blue? Well, I can see yellow in here.
Because I've made it so you can see it with the camera. Otherwise, all you do is just hear it.
Oh, really? So you added a small trace chemical to the bottle such that you could demonstrate it and people could see the little bit of a yellow flame in a classroom with bright lights.
That's right.
But other than that, if it wasn't there, you say we just hear it, we wouldn't see it.
That's true.
But we'd feel if we're too close.
Yeah, of course.
Outstanding. Thank you.
Okay.